Hey everyone, welcome back to another episode of the Futurum Tech Podcast. I am your host, Daniel Newman, Principal Analyst, Founding Partner at Futurum Research. Excited for this interview series brought to you in partnership with Intel. We're going to be talking to Brian Richardson, and we're going to be having a conversation today about something near and dear to my heart and should be near and dear to all of yours, and that is security. But before we jump into this topic, let's go ahead and bring our guest onto the show. Brian Richardson comes from Intel. Super interesting guy. I had the chance to talk to him a little bit backstage, learn a little bit about what his thoughts are on security, and that's exactly why we decided to bring them out to all of you. So, Brian, welcome to the show. How you doing?
Pretty good. Thanks for having me on. And by
Yeah.
on, I mean like on your laptop, because we're not in the same time zone, I think, much less room.
Thanks for inviting me to be a square on your screen. And
it's just rectangles all the way down.
Thanks for not Zoom bombing me. Thanks for getting permission to send these packets. We can talk about all that stuff. Brian, I guess first off, before we jump in, quick introduction and tell everyone about yourself and your role at Intel.
So right now at Intel, I am a marketing strategist for security in the data center and AI group. We call it DCAI for short. We love our acronyms at Intel. Prior to that, I worked in general marketing for security, and I refer to myself as a reformed BIOS guy. I've done firmware since, I don't want to say exactly when, but I did actually write assembly code for money, so that'll give you a date to where I was in that part of the industry. And I kind of learned about security as I progressed through doing firmware evangelism, doing some open source projects related to firmware like Tiano Core or Open Compute Platform, OCP, and have just kind of more drifted into more purely security marketing roles, but more from a high level of looking at kind of the full picture of what we're offering to customers and how we kind of describe the different security problems to customers and how they can actually have solutions for those issues.
Well, just note that I've got bias for people that have BIOS experience. So
yeah,
I practiced that one before we moved on.
Nice work. I have hit delete to enter setup far too many times in my life.
Oh my gosh. So, okay. I got this thesis right now that as we hit this slightly more difficult economic period, Brian, that we're going to see security come more and more into focus. It's one of those things that just can't not be in focus. So let's start just kind of with the macro. In your view, you're in the space, you've been in the space. Kind of how do you see the overall security market? What's happening in this space today and in this current business environment?
Mm-hmm. Yeah, if we look at trends in security, I think the thing that we're thinking about overall in security is that even as spend might go down for a lot of capital investment just in the general compute market, I don't think a lot of companies are in position to reduce or dramatically cut security spending. Now, a lot of these numbers have come out earlier from earlier studies, but if we look at cyber attacks in general, we're looking at more of what's now a cyber crime economy. And I didn't really coin that term myself. If you look at other research companies, say like Mainstream Technologies, they're looking at that cybercrime economy to be like about $1.2 trillion just in 2022 alone. And that is a rough estimate, but again, it's also a rough estimate. This is the amount of money that people are making off of attacks. So now we're looking at cybersecurity being something that a company has to continue investment in, even when they're looking at potential, redirects and spending in other areas. The other thing that we've looked at from a macro trend, along with the fact that most companies are looking at increasing their security spend, increasing their hiring of security talent, is that even if they keep everything up to date, just a software approach alone isn't really cutting it. So let's look at I pulled up a Sophos story from 2019. They're looking at about 75% of companies that were attacked by ransomware. They were running what they consider to be up-to-date security protocols. They had their malware protection, antivirus protection up to date. People are going beyond just the normal software style attacks. And once somebody gets into a network, we work with CrowdStrike a lot. CrowdStrike had looked at the progression. Once you get inside of an infrastructure, inside of a firewall, inside of a VPN structure, you're looking at roughly 2 hours or less to go from the first infected device laterally to a second infected device. So those kind of of trends are showing that security overall, whether you're doing things on premises, or you're doing work at home, you're doing in the office, you're doing cloud, there is a larger need for security overall within an industry, within an ecosystem. And it's motivated a lot by the financial part of the attacks. The cool hacking of the 80s, like let's just dial up a bunch of random numbers, see what the modem connects to, play around with BBS's war drive and people's driveways to figure out if I can get on their Wi-Fi network, which is a thing that friends of mine did in the early 2000s. That has now moved on to entire attack as a service type of infrastructures that we have to defend ourselves against.
Yeah, there's a ton of uh, just visibility to the impacts of security. And it's really interesting, as you kind of mentioned about multi-trillion. You said this is the amount that people are making, and I mean it's crazy that that's A, the case, and B, the other word could
Yeah.
be stealing, misappropriating. I mean, this is money that's supposed to be going one place, and these hackers have been
Hmm.
basically moving this much. And by the way, this expands and changes and creates real impacts to the broader economy. And we've
Hmm.
entered an era now where people don't, well, people do, but it's not about pulling up in your unmarked white van to the bank anymore. It's literally,
Yeah.
with masks on and guns. I know it's Halloween time, the time of year, but it's really now where most crime is being committed behind keyboards in dark rooms, or bright rooms in the middle of days with high speed connectivity, and people that are finding vulnerabilities. And that's something that a company like Intel, when you're building CPUs that are running servers and that businesses are dependent upon, um, it something has to be top of mind for you, Brian. So
Yeah.
I guess talk about that, because people think of Intel, they think about it, they think about their PCs, they think about it with CPUs in the data center. And I think they're, obviously people understand there's a security implication, but I'm not sure everyone understands just how important the role of a company like Intel is in security. Can you just give us a little bit of color on that?
Yeah, we do think about security quite a lot more than people, I think, honestly give us credit for in some areas, whether it's the types of features our customers need, the regulations that we have to comply with, both as a company ourselves and also what our customers have to inherit and turn into products. We're the base of a product for multiple markets, whether we're talking about edge devices in the Internet of Things, your traditional client, gaming PC, laptop type of environment, or data center, cloud, hyperscale, high performance computing. There's a security element in all of that. And because, we're looking at this as, in marketing, I try to be a little bit of an optimist. I don't look at this as a problem. I look at it as an opportunity for a solution. And data protection, it really drives the way that we think about the design of our products and the opportunities we're looking at our customers to get into. So if we look at this from the security standpoint at Intel, um, we look at it as more of a security mindset from a design standpoint, a technology development, the actual ways that our technology gets surfaced or the features get surfaced to a customer, and then the actual assurance and cybersecurity part of it. So, from a mindset standpoint, we're doing a lot of things in the design of our products. Once we're starting at the simulations that years later will turn into as I call it, a magic rectangle made of magic sand. Those processors start out as RTL, they start out as simulations, they start out as a design pipeline in the back of a napkin, 6 years previous. Those ideas have to be developed securely as they go through. Whether we're isolating our own IP or third-party IPs that get incorporated into a design for a customer, whether we're looking at the way that we can update software in the field after something comes out, the way that we essentially firewall parts of the system from other parts of the system so we can perform proper isolation. Those things get extensively designed and tested internally. We do have our own red teams. We also work with a lot of the top researchers through bug bounty programs, or Project Circuit Breaker, which is like an enhanced bug bounty program that we work with select folks on pre-release products, time-bound bug bounties, for instance. So we're doing that as part of internal and external validation before we even release something into the market. The technologies themselves are the way that you kind of get value out of that. So how do we design a technology a customer is going to want and need? And that's a lot of work with our OEM and ODM designers, a lot of work with maybe customers two levels out the door. The old market of designing specifically for a hardware manufacturer, kind of doesn't exist anymore. Now we design more in concert with our end customers, maybe with the hyperscalers that are buying our processors or making, integrating something out of a hardware solution. So the assurance in cybersecurity, I think, is a big part people miss as well, is because once you buy an Intel, let's take a Xeon for instance. Let's put a Xeon into a traditional cloud service rack. They're going to run that for between 3 and 7 years. Basically get as much capital investment value out of that until all the smoke comes out of it. And in that kind of environment, you have to keep those systems up to date. And with the firmware and software components that are on these platforms, we're still continuously putting out updates through a long part of that system lifecycle. So at some point, if there is a vulnerability, and we work with the industry to resolve that through the traditional CVE process, bug bounty process, reporting process, we have a mechanism to keep those customers up to date, so that that machine, even if it's several years old, is still keeping up to date and keeping with the current security trends. So we're trying to make sure that we do that on a cadence. So instead of just like you have we're used to, like, Patch Tuesday, for instance. We have a similar kind of system with our product updates where it's not every Tuesday, but there's a cycle that our vendors can depend on so that they have a chance to validate everything, put it out into the world before all the disclosures come out. So there's an entire life cycle that we're looking at as one of those core component manufacturers for the industry.
Yeah, it's really important that you point that out because you have so many interdependents in your ecosystem. Companies that, you know, Intel Inside. I mean, I know that's not the main marketing campaign anymore necessarily, but Intel legitimately, whether it's in a hyperscale cloud, whether it's in a private data center for an enterprise, whether it's in someone's commercial or personal use PC, Intel's architectures are dependent upon. And whether that's running applications, whether that's at the processor level, whether that's part of the system on a chip, they depend on your company to be continuously on top of the security challenges and making the meaningful upgrades. So talk about it through that lens. Obviously, Intel has to be super focused on building secure products and services for its customers, right?
Mm-hmm.
And then second of all, you have to focus on doing it for your ecosystem. So kind of talk about that inside out approach. How do you start with Intel and make sure you're building the most, restringent, secure products on the planet? And then how do you make sure that your ecosystem can trust that that's coming from you?
Yeah, that's I think the thing that we try to do when we start a design is, one, it's not as insular as you think. It's not necessarily just like six engineers in a traditional, like, let's sit down in the cafe and write something on the back of a napkin. There's a lot of customer input and feedback that comes into that. So the ideas might be internally generated. They may be generated by looking at a trend. They might be talking to customers and saying, hey, you know what, these 6 or 7 customers, they all have the same problem. They all need to isolate data a certain way. They all need to provide root of trust for their systems in a certain way. And that generates the initial thinking of how we develop a product. But the entire thinking we have is that once we create that hardware capability, how do we get the hardware value proven through software? Because if the software can't actually do anything with the hardware itself, then you've just created a space heater. That's an ecological problem, which is another entire podcast series to talk about. But we're looking at the way that you can do things like, hey, what do we already have in a system that might, say, help a malware software be detected early? So if people are trying to sneak around the operating system to install their malware, then how can we, as the processor provider, give information to your endpoint detection that says, hey, you should check out this process, it's doing something kind of fishy. Because at the low hardware level, we can do things like our threat detection technology and our clients, for instance. We can do things like look at the CPU processing telemetry, the same kind of information we use, say, in debugging, and look at the pattern it's running and saying, well, that looks like encryption. Is it the good kind of encryption where you keep your file safe when it's at rest? Or is it the kind of encryption somebody does when they're about to lock your entire system out through ransomware? And that kind of hardware software cooperation through ecosystem companies is one way to get that value out. We're also looking at things like when we accelerate workloads. So let's say we want to Greg Lavender, who's our CTO, talks a lot about post-quantum computing, meaning that at some point, it's not a fixed point in time like Y2K, which we previously dealt with, but at some point, quantum computing is going to get so available that it will be able to very quickly break weaker encryption keys. So now we want our customers to up their encryption strength. That means more compute resources. So how do we help them cut down on the amount of overhead that may take up? Maybe that's offloaded processing through a network accelerator, or through a special set of instructions that handle matrix multiplication faster and are specific to certain kinds of workloads that you can push off and not burden the main CPU with. And one of the larger trends we kind of look at, which has a huge ecosystem behind it right now, is confidential computing, where we're looking at, as more companies want to move stuff to the cloud, well, the software developers now have a problem of they have data that needs to be isolated in some way. There may be a technical isolation that they need to perform through hardware isolation and attestation. There might be a regulatory. A lot of the things that we're doing, a lot of the trends we're seeing in security are not just a cooperation between us and the developer ecosystem. It's also between the ecosystem of generating regulations. So if a lot of people hear the term BIOS and think, well, that's one of my favorite four-letter words in computing, well, so is GDPR. There are a number of regulations that we have to help our customers comply with and help our ecosystem providers, whether they're ISVs, system integrators. The end result is they need to not only perform a service to provide the privacy technology, but also the compliance to prove that it matches the regulations in whatever geospace that they're operating in.
Okay, so Brian, first of all, I'm glad you touched on confidential computing because I'm going to want to talk about that a little more on this particular
Mhm.
question. I think you make a good case for the way the company approaches the ecosystem, and I think it is sort of a lead by in terms of Intel leading with its own strengths, and then of course working closely with your partners to make sure that you're building economies of scale, and B,
Mhm.
the most secure products that they can then bring to market jointly. And that's, by the way, a lot of how Intel's built scale, right? You build scale by
Mhm.
having these partners that implement your technology into their portfolio of products, and that moves a lot of volume. But on the innovation front, so this is that kind of $1 million. I'm going to throw you over the softball. You got the bat. I don't know if you play baseball. Doesn't matter.
Keep in mind, I
Yeah.
used to write assembly code for money, so maybe team sports were not my first priority in school.
Tennis,
Yeah.
badminton. All right. But in all seriousness, I'm gonna lob it over and give you the chance to peg the ball out of the park here. Talk about your innovation a little bit, because that's one of the things that I found to be most interesting. Was I was kind of just
Mhm.
going through all the security innovation, and now when I look at accelerators, I often look at speeding up workloads. I look at speeding up training, speeding up inference. Don't always think about security. That's why I was super excited to talk
Right.
to you. Talk about the innovation that you're making in that particular space to enable all this delivery, all this scale for both Intel and your partners.
Yeah, when you look at security, there's a couple of different problem sets, and it's a big world. So I'm just going to focus on the data center stuff because I think that if we get too far into all the different security scenarios, how long
Fair,
is this podcast?
fair. Yeah,
So let's
not
just
that
look at
long.
data center. Yeah, most of your data center problems come with trying to figure out an idea called a trust boundary. So a trust boundary, let's take an example that maybe not everybody has had in the past couple of years, but is getting back into, which is travel. So look at an airport as a trust boundary. There's a certain area where everybody can hang out. You've got parking lots, you've got lobbies, you've got the weird Uber Lyft pickup, which they moved from the actual airport to like the fourth floor of a parking deck somewhere off site to cut down on the number of Priuses circling the airport. Cool. Now you've got the trust boundary inside, which is I need an airline ticket, an ID, and the TSA background check to go through here. And then you have some people with elevated privileges. They've got clear or pre-check. Maybe they get through some boundaries a little bit faster because they have some additional credentials that puts them inside of this new trust boundary, which is beyond the security gates. Now you have an additional trust boundary where now I want to get on a plane. Okay, there's a re-verification of that. Re-verify the same ticket, re-verify the ID. Maybe an airline has a photo ID verification they use to speed that up. just because you got on the plane doesn't mean you necessarily get to fly, right? There's an additional verification for the pilot, for the flight attendants, for the co-pilot, for the mechanic when they come off and on. So within this area, you're seeing that there are different trust boundaries, even if everybody hangs out on the same plane, for instance, and they're now magically part of the cloud. They literally flew into a cloud. They represent kind of another metaphor for the cloud, which is once I'm on an instance, which part of this do I consider to be mission critical and private versus a more generalized part of this area? So once we start looking at companies that want to move their data into the metaphorical cloud, not the one with the airplanes, then at that point, they have the same trust boundary issue. The traditional security model for data privacy is, in the 80s, it's the computer is in a room, the room has a lock, and outside of that locked door, there's a mean looking person in a blue shirt with an iron on badge and a stick. And if somebody tries to get into the door, they're not supposed to be there, you hit them with the stick. I'm not advocating violence, by the way. I'm pretty much against that. But
No
that's
sport,
an
no
older
violence.
thinking,
Got
like
it.
a physical perimeter, right? I mean, I do take martial arts. If you need some help with the training with a stick, I know a guy, but it's all above board. Don't worry about it. But the idea is that now we've traded some of that for, okay, maybe we don't have the physical perimeter person. We have a badge. We have passwords. We have two-factor authentication. Um, we have different ways of handling that isolation. Once you're on your own premises, once you move things into the cloud, now there's a concern that you've changed your trust boundary and you're relying on a third party to provide that trust. And I'm not saying those companies aren't trustworthy, but you've now changed your mentality from a security standpoint. And the people that you cooperate with, when you collect their data under those various GDPR, HIPAA, the new regulations coming out of China, a lot of the US regulations and guidelines coming from NIST, now you have to make sure that that data, if it falls into a certain category as personally identifiable information or PII, how do you segregate that? And that's kind of where we're looking at these isolations within the cloud infrastructure. So even if you are the machine owner, I own Brian Cloud Incorporated. I need a way for my customers to maintain their own trust boundary within my own cloud. So even if somebody, can sudo on Brian Cloud Incorporated, they still can't see what the customer's data is. There's a certain amount of isolation of that data from the rest of the system, or attestation externally to say, yep, this is the instance I'm expecting. Somebody didn't just pick up this VM from Brian Cloud Incorporated and move it over to a machine outside of his trust boundary, right? There's a way to prove that this is the machine I'm expecting, and that data on that machine is isolated from other parts of the system, other parts of the VM, the operating system, the firmware, so that it has its own little magic pilot's cabin inside of that plane, inside of that cloud. And that's kind of the kind of crux of confidential computing in general, is providing that in a standardized way so that, if I say, let's say that I'm using a consulting company to get my cloud application up and running, they can come up with a solution that works with the underlying isolation and hardware components and keep that separate so that they can comply with, keeping their personal that PII. That's why I make the acronym. It's hard to say. But that's how we keep PII separate in those instances, is we use that confidential computing concept, which is a hardware-software cooperation. We built the hardware fences inside of the Xeon processors so that they are able to take advantage of it if it's implemented at that software level.
And this has been a super hot topic, right? Because data in use is the next big frontier for security. We've talked about in flight and at rest, and we've had that down, but in use, it's been, there's been a new set of vulnerabilities, and this is what you're set out
Yeah.
to solve here with confidential computing. We are kind of getting a little short on time, but I can make some time here because, Brian, I do want to talk a little bit more about SGX.
Mhm.
That's another big one for Intel. Talk a little bit about kind of the motivation, and if you could, maybe even more so, a little bit. Could you share a little bit of like kind of examples of how customers are putting that technology to use?
Yeah. So Intel SGX stands for Software Guard Extensions. That is kind of our fundamental confidential computing technology, and it's the one that's honestly been the most researched, the most deployed in all the industry, and it's the one that has the smallest trust boundary. So within the operating system, you will have applications that are taking advantage of SGX for their attestation and isolation capabilities. So those instances Once they're properly enrolled, they are attesting back to an Intel SGX verification server, and they are isolated through hardware and I/O isolation on that platform. So SGX, we're talking about the three different types of data, right? So data at rest, data in use, and data in transit. So at rest, we all know how to like encrypt files we're keeping on our system. In transit, we're using HTTPS right now to have this conversation, and you're probably using the same technology to view it from a known trusted server. In use is where we really have the biggest problem because you normally have to unencrypt the data, um, you know, basically lay it all out and play with it within that compute space. So SGX is that fundamental hardware technology that Intel provides that allows software to take advantage of that data in use protection. This is called a trusted enclave or trusted execution environment. So if you hear me use the term enclave, I'm referring to that TEE, that trusted execution environment that we set up within a confidential computing enclave. So the uses for this are interesting because they mostly go to where you've got high regulatory issues when you are using personally identifiable information or you're sharing data between multiple parties. So let's take a couple of cases there. In general, if you look at it as a top level, most of your Intel SGX deployments are going to be places that handle a lot of regulated data. So healthcare, financial services. There's a government level concept called sovereign cloud, which allows governments to operate, put their data into a cloud environment, but keep that protected. You can think of a lot of places where, even if it's not like, say, a state secret, there's a lot of government data that's personally identifiable, right? Your social security number, for instance, right? So there's ways of governments having a compliant space for that. So the two that I think of the most is we've done some work with Bosch. So they're coming out with an automated driving system, and they're training that on what ends up being personally identifiable information. So when you drive down a street with some kind of data gathering for driving data, you're getting people's faces, you're getting their license plates, you're getting mailbox numbers. And that kind of stuff, especially in Europe where Bosch is headquartered, is PII under the GDPR definition. So they stratify that data. They separate it out like a Photoshop layer. So the license plates, the people's faces will get moved out into a separate database, but they can't just blur those things out. If they blur out license plates and train the driving robot on that, the driving robot will just, okay, there's no such thing as a blurred number plate in the real world. So they'll just run into cars. I am not a smooth-faced person after all that assembly programming. So, if you train it on smooth faces, people with, visible worry lines like myself are just going to get flattened in the street by robot cars. Don't want that to happen. So, one, I want a self-driving car. Two, I don't like getting hit by cars, turns out. My threat model is pretty ordinary. So in those cases, when they recombine it, that's a data in use scenario. And they may want to share data between multiple instances. They may get their data from multiple providers, but they can't mix that data together in the same database because, again, you end up with a sharing issue. So they can keep that data federated and train the model on it without running into compliance issues. And then in medical research, we did some work a while back with UC San Francisco. And there, again, gathering data from multiple hospitals, which in the US has HIPAA concerns. There are other regulations that are state and federal that make sure they have to protect that data a certain way, but they want to be able to, put that together in a training database to look for trends and patterns in their medical research. So using Intel SGX, it cuts down on the anonymization they have to use, because if they had to further abstract that data before they could put it into a shared pool, one, it's time consuming. Two, it's expensive. And three, it creates a possibility where modifying the data, they might miss a pattern of some kind. And so this allows them to do this kind of wide scale research that comes up with very beneficial medical outcomes.
Yeah, I think the long and the short is there's an opportunity, Brian, to develop technology that can, and this would, by the way, if you start to think about the bigger healthcare problem of why we have not been able to really use EMRs and why people go from hospital to hospital and cannot actually,
Yeah.
You start to think like this is something that as we start to modify the rules, we start to look to the future, to how the cloud, how compute, how databases could enable universal systems to like that to work together, right? Because the reason is with HIPAA is that there's certain data that cannot be exposed. There are very strict rules for that.
Right.
However, if a patient could give permission and you knew that the data could move in transit and be in use and be secure, suddenly some of these problems we're having. I mean, it's amazing in the era that we live in that you could have you could be brought to an emergency room and a doctor cannot see your records for critical care in real time.
Mhm.
I mean, think about how crazy that is. Now, I'm not saying this is going to solve it. I'm just saying it could solve it. You can't.
Yeah.
What great technology does not do is fix bureaucracy. It just doesn't, and that's a topic for
Yeah.
another day. But talk about
Mhm.
something we could have a whole series of podcasts on. Brian, it's been super helpful to have you here. I've kept you long because this topic is so interesting to me. I'm a student of it. I'm passionate about it, and of course, like I said, I think security is one of the most exciting opportunities in the market right now. For enterprise IT leaders, what are you recommending? What is Intel recommending that they focus on to be as secure as possible in the future?
Yeah. I think, and again, I'll stick with more the data center part because that's where my brain's
Yeah,
been
absolutely.
lately. W-
Goes without saying.
Yeah, one is a lot of people, especially with the economic changes. I'll use the nice polished words for economic possibilities of the future. A lot of companies are looking at a transition from a capital expenditure to an operational expenditure model. They want to SaaSify all the things, right? So remember, the cloud is somebody else's computer unless you do it wrong, and then it's everybody else's computer. So you have to start thinking about your constraints when you start moving things to cloud or hyperscale. Is what are your sensitivities around data? What are your regulatory issues? And how do you actually figure out if you are compliant with all of the operational parameters, all the regulations, all the government constraints you've been handed in your particular industry? Second is you really have to think about what hardware the services run on. I mean, SaaS and the general concept of SaaS is great because it allows smaller companies to scale with a lower initial investment, but you don't want to do that at the risk of security. And when you look at, security is basically plumbing. Plumbing is not sexy. It's one of the hard parts of my job is that if I do my job well, nobody notices because there aren't a ton of problems to patch over. So think about it as a plumbing exercise. You have to lay in the base of your secure implementation, and that includes figuring out the right hardware. I do a lot of renovations on my house. My house is 50 years old. I'm fixing a lot of plumbing assumptions that the previous owners made that are incorrect, like the size of a drain pipe probably should have been a little bit bigger. Harder to fix once it's in implementation. And the same thing applies from a plumbing and security standpoint. The minute you notice that there is something bubbling up, it might be a little too late, and you should have thought about that more in the architecture. But don't think that this is a limitation. You need to look for new possibilities. Confidential computing is a good example. This is an opportunity for solution in the data management problem. How can you take advantage of something like confidential computing? Think about, do more possibility thinking. What could I do if I could scale my data? What could I do if moving to the cloud didn't create my compliance issues? And take that approach and engage earlier with Intel or whatever ecosystem partners you work with to figure out if that possibility is there and which providers within their ecosystem will help you solve that problem. And just think about it as an infrastructure problem. You are building a bridge to a future opportunity. Make sure that bridge is stable. It's not a temporary thing to get you across the chasm. It is the foundation for how you're going to operate over the next few years. Because once you lay in this infrastructure, that's an investment. You want to take advantage of that. So make sure it's as secure as possible when you actually do the initial build.
We hit a lot there, Brian, and I like some of those analogies. The plumbing analogy should make a lot of sense to a lot of people. And I also like the fact that infrastructure, something we learn here as a country every day. Um, when you build roads that aren't wide enough for the future, you end up with big,
Yeah.
complicated projects to widen those roads in the future. When you put
Yeah.
in drains that are too small, you end up with clogged drains and you end up with backed up. You can't plant trees too close to the house either. So all these analogies, I think you could apply to security. But I think one of the things that companies have to be thinking about is where and when security gets into focus for the business. I think for too
Right.
long it's been sort of a what's the minimum viable product approach, like what's
Mhm.
the least secure we can be and get away with it. And I think in the midst of this rapid growth of proliferation of AI, of hacker sophistication, of zero trust being a board level concern, partnering with companies that are putting security in focus and to getting security right is going to be a non-negotiable. So, Brian,
Yeah.
I want to thank you so much for joining me here on the Futurum Tech Podcast interview series. Great talking to you. There's a ton of information here. Hope I can have you back again soon.
Yeah, hope to do it. I won't have to travel far if we keep doing it in the rectangles, but hopefully we can do the next one sitting in some chairs.
Yeah, chairs or, outside or surfboards, not playing baseball.
Next to a bridge to illustrate all of our. We'll find a nice bridge somewhere around Portland, and
It'll be a metaphoric show with tons of visual support. Brian, thank you so much for joining the show. Hey, everybody out there, check out those show notes. We're going to put a bunch of links to some of the things that we talked about throughout the show. Learn more about Intel security, and of course, focused on the DCAI business. They do love their acronyms, although as an industry tech analyst, I can tell you it's not unique to Intel. We'd love to have you as part of our community. Hit that subscribe button. Follow us on Twitter and on social across the board. Lots of great interviews like this one on the channel. But for now, I got to go. Thanks for sticking with us for this one. We'll see you all really soon. Bye-bye now.